Okay, let's start now. So welcome everyone. I am teacher Kevin from Think Academy. And today we're going to look at simultaneous equations, which is a very exciting and interesting topic. So simultaneous equations, they always appear in 11 plus exams as hard questions, yeah? So medium or hard questions. So which is why we would like to be happy with this knowledge point with simultaneous equations. So enough being said, let's have a look. So there are three types of simultaneous equations. Yeah, the first type is the medium or less than below medium. So some maybe simple questions. Let's look at an example for the first one. Simple simultaneous equations. Say I have a simultaneous equation over here. I have 3x plus 2y equals to 35. That is equation 1. And then I have 2x plus 2y equals to 30. And that's equation number 2. Yeah. So for simultaneous equations, what do we dislike about simultaneous equations? Yeah. So according to observation here, you find that we have two variables. Yeah, so we have two variables. We are not comfortable with solving simultaneous equations with two variables. But what we are comfortable with is solving linear equations with just one variable. So for example, 2x plus 5 equals to 15. This one we can solve, right? So with that being said, what we want to do is simple. Just eliminate one of the variables. Yeah, we want to change this simultaneous equation into a linear equation, which we are comfortable with, which we're confident with. Yeah. So how do we do it? Yeah. Can someone give me a guess in the chat box? No. Okay. Nobody gave me an answer in the chat box, so I'll just go through it. So what we can do is we can do subtraction between these two equations. Why? Because here, let me change. Okay, subtract. Yeah, that's correct. Subtract. Good job. Let me change the color. So here, if we look at here, the coefficient. Yeah, coefficient is a fancy name for the number before the variable, before the letter. Yeah, so the coefficient for y is the same. So 2y, 2y. Yeah, say I have 2y. And say Irvin has 2y, then what mathematical operation do we do to cancel out these 2y? That is correct. We use subtraction. Yeah. So we use, remember that we always take away the smaller one from the bigger one. So we take away equation number 2 from equation number 1. Yeah. And the logic for doing subtraction between equations is like this. Yeah, it's pretty simple. So we just consider the left-hand side of both equations first, and then we consider the right-hand side of both equations. Yeah. So I see lots of you have already given me the answer. So let's just do this quick. The left-hand side will be 3x plus 2y, yeah, brackets, because we're treating them as a whole. Can we all mute ourselves, please? Because there's an echo. And then take away, because we're doing subtraction here. And then bracket, we're treating the left-hand side of the equation 2 as a whole as well. So 2x plus 2y. And it's equal to 35, take away 30.
Awesome.
Yep. And then what should we do next? We open the brackets. So we remove the brackets. So let's have a little recap on how to remove brackets. So remember, there is an invisible plus, yeah, an invisible positive sign over here. So if we remove the brackets, because it's positive in front of the bracket, we don't need to do anything inside. So 3x plus 2y, just write it like this. Absolutely no problem. And then here, for the second bracket, because we have a minus sign in front of the second bracket, so when we remove the brackets, we have to swap the signs. We have to change every sign inside the bracket. So the plus sign will become minus. So minus 2x minus 2y, which is equals to, the right-hand side will be 5. So we see here plus 2y minus 2y. This is what we like to see because they cancel out. We don't need to bother we don't need to bother as well anymore. What's left is just 3x take away 2x. Yeah, 3x take away 2x. Everyone can do that. X equals to 5. This will give us 1x, the value of 1x. And then what do we do next? Yeah, what we do next is we plug this result, the result for x, back into either one equation here. Yeah, so one of these two. Say if I plug x equals to y back to the first equation, then x equals to 5 will be 3 times 5. Yeah, and then plus 2y equals to 35. This is, yeah, so see what I mean? We change the simultaneous equation into a linear equation with just one variable, which we are confident with, which we can solve. Yeah, so that is 15 plus 2y equals to 35. So remember how we do this? We move all the letters, we leave the letters on the left-hand side of the equation, and we move all the numbers to the right-hand side of the equation. And so we have to move this term, this 15, to the right-hand side. Yeah, so we move the term, and remember, when the 15 goes to the right-hand side of the equation, this invisible plus, the positive in front of it, will become negative. So 35 minus 15. So 2y equals to 20, and congratulations to all who got x equals to 5, y equals to 10. That is the correct answer. And remember, we always want to write our final answer in this format. X equals to 5, y equals to 10. Yeah. Okay. Yeah. Sorry, I think I should write it with the pen in the classroom. Okay. Yeah, so I have two practice questions. I have one practice question for this one, just so you can have a think, have a try. Here. Say I have 5x plus 3y equals to 70, and 4x plus 3y equals to 62. So this is an example. Everyone can pull out your pen and paper. I'll give you 3 to 5 minutes, and you can type your answer in the chat box. So meanwhile, I will complete the steps over here. Aaron got it correct. Kathy got 1 correct. And Rachel got it correct. Good job, everyone. Okay, good. Let me see in the chat box. Okay, looks like everyone is happy with this first type of simultaneous equation. Very good. Then let's look at another type of simultaneous equation. So I need another page. Okay. Okay, let me just write it here. So it's a little bit, it's a small space. Say we have 3x plus 2y, sorry, not 2y, should be 1y. So 3x plus y equals to 35, and then 3x, not 3x, x minus y equals to 5. Equation 1, equation 2. For this type of equation, do we still do the subtraction between equations? Do we do that? Can you tell me in the chat box? If not, yeah, Mina? Yes, no? I see 2 answers in the chat box. Can you repeat? Sorry?
You have to add it instead of subtract it.
That is correct. Yeah, so we do not subtract these two, because if we subtract, Yeah, remember, so if we do subtraction between the two equations, there's another fast method. We can just do it separately for each term. So 3x minus x is 2x, and then y minus y will be y plus y. So it's plus 2y equals to 35. Take away 5 is 30. So we find that we haven't eliminated any variable. Yeah, that's not what we want to do. What we want to do is always eliminate one of the variables, make it into a linear equation, solve it, and then plug it in, make another linear equation, and solve for the other. Yeah, so eliminate variable. That's what we want to do. So good job, Mina. That's correct. We want to add these two equations. So 1 plus 2. That should give us 4x equals to, this is plus y, this is minus y. When they add together, they cancels out. And then 35 plus 5 is 40. Then 1x will be 10. And then plug x equals to 10 back into equation number 2 because it's obviously easier to calculate. So 10 take away y is 5. Then y will be 5. So y is 5. And then we present or answer in this format always. So easy peasy. And then another example. So example number 1 and example number 2. Another example about addition method is 5x plus 3y equals to 70. And then 5x take away 3y is 10. Yeah, can I have a try? See in the chat box. You can type in the chat box how much it is. So Aaron, are you still confused? Yeah, is everyone happy with this? Can you type in the chat box if you're confused or if this method is clear to you? Or you can just open the mic and tell me if it's clear or not. Not confused?
Not confused.
Okay. Nope. I have no idea. Oh, Sophie is so confused. So which part are you confused? You can open the mic and tell me. Yeah, is it the plus y take away minus y? Is that part confusing?
I wasn't here for most of it, so I don't really understand.
Okay. If you have any question, if you're late, you can ask me after the lesson. I will explain it to you. Yeah, is that good? Kathy, very, very good. Okay. Yeah.
I
So
think this one works.
which one? Yeah, Mina, which one?
No, sorry.
Okay, so we're looking at example number 2 right here. So you can have a try using the addition method we just said. That is correct, CC. Good, Mina. You got X correct. Okay, Kathy. Yeah, Mina got the second one correct as well. Good job. Okay, Sophie got X equals to 8, which is correct. Very good. Okay, 30 more seconds, everyone. Type your answer in the chat box, and then after 30 seconds, we'll move on. Yep, Kathy, that is correct. Wilson, correct. Irvin, correct. Yashi, your Y. Oh, wait, X equals to 10, Y equals to 5. No, that's not the answer to this, to example number 2. We're looking at example number 2 now. Yep, very good. Okay, yeah, time's up. Most of us got it correct. Very good. So to have a little summary, the subtraction method, it always appears in 11 plus exams. The addition method, it seldom appears. So we just need to be happy with the subtraction method. So the first method I said, the first scenario, okay? And a little summary, let me switch to red. So here, conclusion. So for the variable, which means a fancy name for letter, so for variables with the same coefficients. And the coefficient is also a fancy name for the number before this letter. Yeah, so with same coefficient. If we have the same sign in both equation 1 and equation 2, say we have plus 2y and plus 2y, yeah, or we have minus 2y in the first equation and minus 2y in the second equation as well. Yeah, so same sign. Then what we do is subtraction. And if we have different sign, then what we do is addition. Yeah, so say we have, like here, plus y minus y in equation 1 and 2 respectively, then what we do is addition. So the core thinking is always we want to eliminate one variable, which makes life easier. Okay. So let's look at an example question. So here, a balloon pump and 3 packs of balloons cost £9 altogether. A balloon pump and 4 packs of balloons cost £11 altogether. Question number 1, how much does a pack of balloon cost? And question number 2, how much does a balloon pump and 8 packs of balloons cost? Yeah, everyone, take your time, have a try. Yeah, very fast, Aaron, and then also correct. Leon also got it correct. Yep, Hugo also got it correct. Good, good. Okay, yeah. So question number 1, all of us got it correct. And then look at the question number 2. Good job, Aaron. Question number 2 also correct. Good. Good. Hey, 10 more seconds. Okay, £2, 19, sorry. Okay, so looks like everyone is happy with this question. I'll just quickly go through it then. So first question, so we have 2 sentences here, 2 conditions. We can use them to set up 2 equations for simultaneous equations. So a balloon pump, I will use P, capital letter P, to represent that. So 1 balloon pump and 3 packs of balloons plus 3 balloons, they cost £9 altogether. That's the first equation. And then the second equation is 1 balloon pump, 1P, plus 4 packs of balloons, so 4B, is £11 altogether, so 11. We have our simultaneous equation. And remember, we always want to take away the smaller one from the larger one. So equation number 2 minus equation number 1. Sorry. It should give us, by observation, P minus P cancels out. Don't need to bother. 4B minus 3B is 1B. And then 11 minus 9 is 2. So 1 pack of balloon is £2. Congratulations to all those who got it correct. And then the second one. How much does a balloon pump and 8 packs of balloons cost? So we have to find out how much does a balloon pump cost as well. We can plug this B equals to 2 back to, say, equation number 1. So P plus 3 times 2 is 9. So P plus 6 is 9, and then P will be £3. So 1 balloon pump is £3. Yeah, so we can write this. We can write the second equation, second question as this expression. So 1 balloon pump plus 8B. So that will be 3 plus 8 times 2, 3 plus 16, which is £19. Correct. Congratulations, everyone, who got it correct. Well done. Can I go back to the conclusion? There is a playback if you are late for the revision class. Yeah, there's a playback. You can look at it after our session. But sure, if you want to look at the conclusion, here it is. So the conclusion is for variable with the same coefficients. In this case, plus 2y and plus 2y. So 2y and 2y. Yeah. If it is the same sign before it, so plus, plus, or minus, minus, then we will do subtraction between the 2 equations. If the sign in front of it is different, say plus 2y and minus 2y, or minus 2y plus 2y, then what we do between equation number 1 and equation number 2 is addition. Okay, let's move on quickly. So second question. A shop sells bananas and pears. Max buys 1 banana and 2 pears. He paid 94 pence. And Emily buys 1 banana and 1 pear. She paid 62 pence. How much does 1 banana cost? Everyone, have a try with this question. You can type your answer in the chat box when you're finished. Okay. Oh, I got different answers now. Someone says it's 32 pence. Someone says it's 30 pence. How much is it? Okay, good job. P. 30 pence, correct, good. Yep, okay, it seems like everyone is happy with this one as well, so we'll just quickly go through it. So Max buys 1 banana, I'll use capital letter B to represent banana, and 2 pears, capital letter P. And he paid 94 pence. And then Emily buys 1 banana and 1 pear, and she paid 62 pence. Okay, so remember, we're dealing with pence here, so the units matters. Pay attention here. So this is equation 1, equation number 2, and take away the smaller one from the larger one. So equation 1 number 1 minus equation number 2, 1b minus 1b cancels out, and then 2p minus 1p will give us 1p, and 94 pence minus 62 pence is 32. Yeah, that's 32 pence. And then we plug this back into equation number 2, which will give us 1 banana is 30 pence. Correct. So for the answer who got 32 pence, you got pear. Yeah, you got the cost of 1 pear, but we're looking for the cost of 1 banana. Okay, so let's move on. Good job, everyone. So now, before we move on to the second part, to the second type of simultaneous equations, we have to look at we have to be happy with this knowledge point I'm going to talk about. Yeah. So for example, if I have A plus B equals to C, I have an equation over here. Yeah. You have to be happy with this. Yeah, yes, Xichen, or is it Chen Xi? What is it?
That was an accident.
Oh, that was an accident. Okay. So we have this equation here. I say if we enlarge the whole thing, let me use red. If I enlarge it by a proportion, yeah, or I reduce it by a proportion, yeah, say I time 3. So I enlarge this whole equation 3 times, or I halve this whole equation. This equation still stands. Everyone agree? If you agree, can you type agree in the chat box? So that means if I time 3 to all the terms inside this equation, yeah, so 3a plus 3b equals to 3c, then this equation, it's basically the same thing. Yeah, nice. Okay, good job. Happy to see everyone is happy. And then if I reduce this equation by 2, say a half a plus a half b equals to a half c, then it's still the same thing. Yeah. So keeping that in mind, good job, everyone. Keeping that in mind, let me write another equation right here. Let's say we have 3x plus 2y equals to 40. And then we have 4x plus 3y equals to 55. And this is equation number 1. This is equation number 2. So if by observing, I'm sure most of you are frowning right now because we don't have a variable that has a same coefficient, right? So we cannot just do simply addition or subtraction, correct? So what should we do instead? Yeah, you can type your guess or your assumption in the chat box. So for this second type of simultaneous equation, what should we do? How do we eliminate one variable so that what's left is a linear equation and we're comfortable with? Okay. Okay, so let's see. Let me change to red. So remember, the core thinking is always we want to eliminate one variable, right? And teacher Kevin always want to eliminate y. because he hates y. He loves x. Yeah, so I want to eliminate the y. But here, if say I take away equation number 2 from equation number 1. Sorry, equation number 1 from equation number 2. Then what's left is x plus y. Yeah, 4x minus 3x, 3y minus 2y is 55 minus 40. X plus 5 is 15. Yeah, so we didn't eliminate any variable. So what we do is, remember, we can't do addition or subtraction between variables with same coefficient, right? So we just we do mathematical operations to let this coefficient of y make them the same. So this 2 over here and this 3 over here. Yeah. So we find a number which is a multiple of 2 and a multiple of 3 as well. We find this number and we put it into this box. Yeah. So if it is a multiple of 2 and a multiple of 3, what do we call it? Yep, we call it a common multiple, right? And just so we do it the most convenient way, we find the least common multiple, LCM. I'll write the full name. Least common multiple. So what's the least common multiple of 2 and 3, everyone? Yeah. So if I say this, because 2 and yeah, that's correct. Well done. Because 2 and 3, they are co-primes. So to find their LCM, we just simply use 2 times 3, which is 6. Very good. Good job to whoever said that. And then what do? Remember I said here that we can enlarge or reduce one equation by same proportion and the equation still stands. So how do we get 2? How do we get 6 from 2? We time 3 to equation number 1. Yeah, so that means we have to time 3 to each term respectively in equation number 1. So we get 3x times 3, 9x, plus 2y times 3, 6y equals to, remember, this 40 also has to times 3 as well. So we have to write 120. So lots of students make mistakes here. They write 40 instead of 120. That is not correct. Yeah, we have to write 120 over here. And then we write, how do we get 6 from 3? Yeah, we use equation number 2. We time 2. So that will give us 4x times 2, 8x, plus 3y times 2, 6y equals to 55 times 2. That's 110. Okay, so say this is equation number 3, and this is equation number 4. And then we take away the smaller one from the larger one. So 3 minus 4, that will give us x. So 9x minus 8x is x. And then 6y minus 6y cancels out. 120 minus 110, that will give us x equals to 10. Yeah, and then we plug this x equals to 10 back into equation number 1 or equation number 2 or 3 or 4. It's arbitrary. So which one you see fit. Yeah, so if we plug it back to, for example, equation number 1, so we will have 3 times 10 plus 2y equals to 40. And that will give us 2y equals to 40 minus 30, 10. Y equals to 5. And congratulations to everyone who got x equals to 10, y equals to 5. That is the correct answer. Yeah, just remember, we always write it in this format. Very good. Well done, everyone. So the core thinking is, yeah, for this type of simultaneous equations, we have variables with different coefficients. Yeah, we find its least common multiple, and then we make the coefficient the same, and then we do addition and subtraction. Yeah, repeat what we did with the first type. Yeah. To this step, is everything clear? Does anyone have any questions? Yeah, if it is clear, you can type clear in the chat box so that I know everything is clear for you. Clear, okay, good, clear. Nice, everything is clear. Clear as water. I like that saying. Okay, so that means we can look at example questions here. At Washington's math shop, you can buy 3 protractors and 5 rulers for 1.55 pounds, and 6 protractors and 9 rulers for 2.88 pounds. Find the cost of 1 protractor and 1 ruler. Have a go, everyone. You have 2 minutes. And also, if you have done this problem, you can look at this example practice question as well. So example 1, I only prepared one practice question for this second step, for this second type of simultaneous equation. 6x plus 3y equals to 54. And then 7x plus 9y equals to 85. So that's the first equation, that's the second equation. Yeah, so when you're finished with this example question right here, you can look at this one. The numbers are a bit weird for this practice question, but that's the point. 22, 15, 37. Yeah, Aaron, you got it correct, the total. But if it's looking for the total cost, it will write total cost over here. So right now we're just looking for the cost of one protractor and the cost of one ruler. So so separately. Okay, so very quick and correct as well. Good job, everyone. And for those who have solved this standard example, you can move on to the practice question on the left-hand side. Good job, Yushan. Good job, CC. Good job, Wilson. Correct. Correct. Good. Nice, Simon. Good job, Sophie. That is correct. Leon, also good. Cindy, Yuxuan. Yeah, for those who keeps typing total too in the chat box. So remember, we're looking for the cost of one protractor and one ruler respectively. Okay. So if we're looking for the total cost, the question will be find the total cost of one protractor and one ruler. So you might want to pay extra attention to the question during 11 plus exams. Yeah, because if you're in the actual exam and you write 37 for this question, that would be wrong. You will lose points, which we do not want. Okay, good, Olivia, good, Ruth. Correct. Good job. I don't know how to pronounce this name. Correct me if I'm wrong. Is it Depeche or Depeche? Good job, Helen. Also correct. Yep, we got our first answer for the practice question. Leon got it. Okay, I won't tell you if you got it correct or wrong, just to leave some chance for others. She got 37 pounds. That's 37 pence. Hugo got it correct. Good. Okay, we got the second answer. CC. Good job, CC. That is correct. Yeah, Leon, it is right. It is right. I'm just leaving some time and chance for others to have a try for the practice question. Good job, Rachel. Good job, Aaron. Okay. Now, let's see. Let's have a quick go through because I see all of you have got the correct answer for this one and the practice question as well. So 3 protractors and 5 rulers. So 3p plus 5r is 1.55. So I'll skip the pound unit, and then 6 protractors plus 9 rulers is 2.88 pounds. So we have our simultaneous equation. And then, yeah, for this one, to find the common multiple of 5 and 9 is definitely more difficult than finding the common multiple of 3 and 6, right? So we only make the coefficient of p the same. And how we do it is actually even more simple. So the first equation times 2, yeah, everything times 2. So 3p times 2 is 6p, and then 5r times 2 is 10r, equals to 1.55 times 2, which is 3.10. And this gives us the third equation. And then the smaller one, we take the smaller one away from the larger one, 3 minus 2, and that will give us 6p minus 6p, cancels out. Happy. And then 10r minus 9r is 1r. So one ruler is 3.10 minus 2.88. So that should give us 22 pence. Sorry. So that's the cost of one ruler. And then we plug this back into equation number 1. So 3p plus 22 times 5. Oh, yeah. So we're working with pounds here. So I'll just let all the units equals to pounds. So it should be 0.22 pounds. Yeah. So 3p plus 5 times 0.22 is 1.55. So 3p plus 5.5 times 0.22 is 1.10, which is equal to 1.555. And then 3p will be 1.55. Take away 1.10, which is 0.45 pounds. And then 1p will be 0.15 pounds. So congratulations to everyone who got these correct. And remember, we're going to write our answer in the form of one protractor. So p is 0.15 and one ruler. So one ruler is 0.22. Yeah, we do not write the total. Yeah, that's not what we're looking for in this question. And then for this one, let's do this one as well. So we want to find the least common multiple of either the coefficient of x or the coefficient of y. And by observation, we find that 9 is a multiple of 3. So we just need to times 3 to equation number 1. This lesson is 1 hour, so it will end at 7 p.m. Don't you worry. 1 times 3 will give us 18x plus 9y equals to 54 times 3, which is 162. And then this is our equation number 3. And equation number 3, take away equation number 2, because we're taking away the smaller one from the larger one. Cliche, 18x minus 7x is 11x. And then 9y minus 9y is cancels out. And then 162 minus 85 is, let me see how much it should be, 77. And then x equals to 7. And then we plug x equals to 7 back into equation number 1. 6 times 7 plus 3y is 54. So 3y equals to 54 minus 42. So 3y is 12. 1y will be 4. And then we represent our answer in the form x equals to 7, y equals to 4. Good. Okay, so up till now, for these two questions, is it clear? Everyone happy? You can type either clear or happy in the chat box. So if it is 7:38 at your place, then for you, it will end at 8 o'clock. Happy. Okay, everyone happy. Good. Let's move on. Let's move on to this standard example question. Everyone have a try. So 7 files and 4 storybooks cost $108, and 5 files and 3 storybooks cost $80. So find the total cost. See here? See what I mean? Now, I will give you a wrong if you give me the cost of 1 file and 1 storybook separately. Yeah, we're looking for the total cost now. And I also come up with another example right here, just so you can have more practice. I want a hard number for all of you, because you all did the question so quickly. Okay, Nicole, Aaron, good job. Why dollar, not pounds? Because say we're at a store in America. So in a store in America, 7 files and 4 storybooks cost $108, and 5 files and 3 storybooks cost $80. Yeah, find the total cost of 1 file and 1 storybook. Good job, everyone. 24. Good. It is 24. Okay, $24. Yeah, units is also very important. So be careful not to write pound for this question. If you write pound, you will also lose marks, which we do not want. So let's quickly go through it. So 7, I'll use small f. Actually, I'll use capital letter F to represent files. Plus 4 storybooks costs $108, and then 5 files plus 3 storybooks is $80. So we find the least common multiple. In this case, if you look at it through observation, yes, the least common multiple of 3 and 4, to find it is definitely easier than finding the least common multiple of 5 and 7. Although they also co-prime. So what we do is just 5 times 7 and 3 times 4. But 12 is smaller than 35. So we want to deal with equations with smaller numbers. It is easier for us to calculate. So we make the coefficient of s the same. So we time the first equation by 3, which will give us 21f plus 12s equals to 3 times 108. Fast calculation, everyone. 324. And then the second one, we use the second equation times 4 to get 20f plus 12s equals to 320. Yeah, and then this is equation 3 and equation 4. Then we take away 4 from 3, and that should give us 21f minus 20f is 1f. 12s minus 12s cancels out. 324 minus 320. 1f will be $4. Yeah, and then we plug this 1f back into, say, I want to do equation 2 not this time, just to show you that you can do either equation 1 or equation 2, the way you see fit. So 5 times 4 plus 3s is 80. So 20 plus 3s is 80, and then 3s will be 60, 1s will be $20. So, oops, sorry, I shouldn't write it in this way. We're looking for the total cost of 1 file and 1 storybook. So S plus F is $24. Okay. Congratulations to everyone who got 24. You got it correct. Hooray. Good job. Hooray. Okay, now let me have a think and try to give you this harder practice question. So 29x plus 27y is 83, and then x plus 17y is 35. Yeah, have a go, everyone. Have a go with this question. This is equation 1. This is equation 2. So we want to practice until we're absolutely happy with these second types of simultaneous equations. We have to be fast and we have to be correct as well. So just I'll read the question again. So 29x plus 27y equals to 83, and then x plus 17y equals to 35. Yeah, that's equation 1 and equation 2. I'll have a go as well. Yep, it is no problem. I'm having an absolute stagnant, still chat box over here. Is everyone thinking? Everyone working out the answer? Still thinking? Okay, take your time. So the calculation for this one is indeed a little bit annoying, but that's the point. Yeah, because in the 11 plus exam, the numbers will not be very comfortable for you. It will definitely be like this. $24 again. Hard, annoying. Yeah, that's the point of exams, right? Just kidding. It's not the point of exams. The point of exams is for the teacher to see how you do it, not to annoy students. Still thinking. So Hugo said 24 again. Do you mean the answer is 24? Exams even more hard, annoying. Yeah. No, when I was a student, I used to think exactly the same thing. But I'm sure you will all be all right. Okay, so I will give everyone 4 more minutes to work out the answer. 4 more minutes, everyone. You are stuck, you don't know. So Simon, are you stuck with the calculation?
Yeah.
Okay. So which part are you stuck? Finding the least common multiple?
Yeah. Yeah.
Okay, x equals to 20, y equals to 27. Well, Olivia, let's see. So I have x equals to 20. Let's see the second equation. Let's plug them back and have a check. Yeah. X equals to 20, y equals to 27. So 17 times 27. Is it 35? Doesn't look like 35. This question is made wrong. Is it? What is the question again? The question is right over here. So this is practice number 2. So 29x plus 27y is 83. And then x plus 17y is 35. Yeah, good job, Leon. This is definitely right. Very confident. I like it. That is correct, Leon. Wilson, correct. Good job. Okay, so let's give the others 2 more minutes to think about it. Aaron, good job. Olivia, good job. So you see, it's not made wrong. It is correct. Almost done. Yeah, take your time. How long is this lesson? And is it every week? Yeah, it is every week. This lesson is 1 hour long. Actually, we are just 12 minutes to ending. So you can look at the playback after we finish. Hugo, don't get it. Don't worry. We'll go through it together. Okay, x2, $3. What does the $3 mean, Yashi?
X equals 1 and y equals 2.
Ah, right. $3. Okay. So the total cost. Okay. No problem. So you're buying 20. Oh, you're still doing it like the files and storybooks. It's okay, but this practice question is just numbers, calculations. The $7 in total. Yeah, that means you got the x equals to 1 and y equals to 2, correct? Good job. Yeah, Michelle, good job. Simon, also correct. Rachel, correct. Yeah, she, good. Helen, good. Everyone, good job. Yeah. Okay, so let's go through it together. So everyone, pay attention. I'll use another color. Let me use green. So we want to make the coefficients the same, right? Find the common multiple. So here x, before this x, there is a 1 over here. remember? And then the 27 and 17, do they co-prime? Yes, they do. They are co-primes. Yeah, that means they have no common factor apart from 1. Yeah, because 7 is a prime number, so they must co-prime. Yeah, to find the least common multiple between co-prime numbers, what we do is we just multiply them. Yeah, so 27 times 17 will give us the LCM of these two numbers, of the coefficient of y. Yeah, if you think about it, 27 times 17 compared with we just enlarged the second equation by 29 times. Yeah, makes this 1 into 29. 29 times 1. Which one looks simpler? Which one seems easier? Obviously, the first one, right? So what we want to do is we make the coefficient of x the same. So what we do here is erase it. We enlarge the second equation 29 times. So 29x plus 29 times 17. I'll do a quick calculation over here. 9 times 7, 63. This is 3, 6, 2, 14, 20, 29, just 493y, which is equals to 35 times 29. 5 times 9 is 5. This is 4. 27, 3170, 1015. Okay, that is quick. Should be. And then take away, this is the third equation. And then we use the third equation minus the first. The 29x minus 29x cancels out. Very good. And then 493y minus 23y is 466y. It will be 283. So this is 2. This is 9. So 932. Yeah, if you're number sensitive, if you've done lots of multiplication, division, you will see these two numbers very familiar because 466 times 2 is 932. So y is 2. And then we plug this y is 2 back into the second equation because it makes life super easy. So 2 times 17 is 34. And then 34 is just 1 away from 35. So x is obviously 1. That is the answer to this question. Everyone happy? Everyone clear? Type a clear. Yeah, happy or clear in the chat box if you're okay with this second one. So the only thing that is annoying is this big number calculation. So lots of multiplication, lots of addition. Yeah, other than that, the core thinking is exactly the same. Yeah, identical, no difference. Let me see. Happy, happy, happy. Good job. Okay. Now let's move on to the third type. So the third type is actually my favorite type. So say we have, oh, I'm still using green. Say we have 3x plus y, 3x plus 2y equals to 22, and 2x plus 3y equals to 23. This is equation 1. This is equation 2. So let's observe this simultaneous equation. This is the third type. So what do we find? Clear, good, Urban. So we find that the coefficient of x, yeah, in the first equation, the coefficient of x and y respectively is 3, 2, right? But in the second equation, we get 2, 3. So we have swapped the coefficient in these two equations, correct? So for this type of equation, so for this type of question, how do we find x and y quickly? Let me see in the chat box. X equals to 4. Oh, so okay, so I got submission with answers already. Let's go through it. So what we do is really simple. We just add these two equations together. Yeah, because this is 3, this is 2, this is 2, this is 3. That means if we add these two equations together, we will have the same coefficient for x and y. Yeah, so 3 plus 2 is 5, and 2 plus 3 is 5 as well. So that will give us 5x plus 5y equals to 22 plus 23 is 45. And then remember what I said about at the second part, that we can reduce this equation, the whole thing, by a proportion, and the equation still stands, right? So we can divide the 5 to each term respectively. So that will give us x plus y is 45 divided by 5 is 9. So x plus 5 is 9. So this is really important. This 1x plus 1y is really important because most of the 11 plus exams, so not most of them, but lots of them, they just stop here. So they will ask, can you tell me what is the total cost of 1x and 1y? And then you can just tell them it's 9. Yeah. And then if you want to find out x and y respectively, it's also very easy. So say we have x plus y is 9 over here. And then remember, we can time this whole thing. We can enlarge it 2 times. So 2x plus 2y is 18. And then we compare it. This is the third equation. We compare it with the first equation. So 1 minus 3, it will give us 3x minus 2x, 1x, 2y minus 2y cancels out, is on the right-hand side of the equation, 22 minus 18, 4. Yeah, x equals to 4. And then we plug this back into this equation over here. So 4 plus y is 9. So congratulations to everyone who got x equals to 4, y equals to 5. That is the correct answer. Okay. Yeah, so a little summary. Summary is for this swapping, yeah, swap coefficient type of questions. What we do is we just simply add the 2 equations. The coefficient of the result of x and the result of y, the coefficient of x and coefficient of y will definitely be the same. Yeah, trust me. Let's look at an example, shall we? Just to prove what I said is correct. So I have 4x plus 3y equals to 27. And then 3x plus 4y is 22. This is an example question. This is equation 1. This is equation 2. How do I want to know what is 1x plus y? Yeah, can everyone give me the answer in 1 minute? Should be easy, should be easy. Do it quickly. Yeah, so this is a neat trick for special case of simultaneous equations where the swap coefficient type. X plus y, 7. Leon, always the fastest. Good job. 8. Nicole got 8. Eric got it correct as well. X plus y is 7. Good job. Mina also correct. 7. Good job. Okay. Yeah, she got it correct. Michelle got it correct. Good job. Good, everyone. Helen. Hey, let's go through this together very quickly. Yeah, good job, everyone. Almost everyone got x plus y equals to 7. So let's see. So 1 plus 2. Yeah. The repeating this method over here. So 1 plus 2 will give us 4x plus 3x is 7x. And this is 3y plus 4y is 7y as well. And then 27 plus 22, 49. And then divide the 7 to every term in this equation. The equation still holds. X plus y equals to 49 divided by 7, 7. Yeah, so 1x plus 1y is 7. And then, good. And Rachel even got x equals to 3 and y equals to 4. So she got them each. Let me see if it is correct. So this is 12 and this is I'm afraid x is not 3 and y is not 4. Try again. Yeah, everyone. Can you try to find out what is x and y respectively? Yeah, we know x plus y is 7. Remember, so you see what I've done here. If this is 4x plus 3y, then we can just enlarge this equation by 3, and that will give us 3x plus 3y is 21. Oops. 3x plus 3y equals to 21. Why can't I? Yeah, 21. And then we subtract 1 with 3, which will give us 4x minus 3x, 1x equals to 27 minus 21, 6. Okay, let me see who got x equals to 6. Aaron, good job. Sheldon, good job. Rachel, good, good. CC, yes, that is correct. Sophie, correct. Leon, good. Yashi, good. Nicole got x equals to 3 and y equals to 5. Okay, Nicole, so you see here, we first got x plus y equals to 7. So for if x is 3 and y equals to 5, then x plus y is 8. Yeah, that is not correct. Have another think. Good, good. Okay. Okay, so most of us understand and that y equals to 1. Okay, good. Let's look at the last question for today. So Ellie pays 1.5 pounds for 2 bananas and 3 apples, and Beth pays 1.545 pounds for 3 bananas and 2 apples. How much does Annabella pay for 1 banana and 1 apple? See what I mean? So usually, most of the questions will just stop at how much do we pay for 1 banana and 1 apple. So 1 banana plus 1 apple. So just stops there. So because we are out of time, I'll do it for you. Let's do it all together. So 2 bananas plus 3 apples is 1.50 pounds. And then 3 bananas plus 2 apples is 1.45 pounds. This is equation 1. This is equation 2. 1 plus 2. Very quickly, everyone. Very quickly. 5 banana plus 5 apples equals to 2.95 pounds. And then divide 5 to each term. That gives us 1 banana and 1 apple will be 2.95. Let's do a short division just to give a recap. Division involving decimal points divided by 5. So 0 point. Align the decimal points because 2 is less than 5. So 0 point over here. And then we consider a 29. 29 divided by 5 is 5, remainder of 4. And then make this digit come down. We get a new number, 45. 45 divided by 5 is just 9. 0. So no remainder. So the answer is 0.59 pounds, which is also 59 pence. So both correct. Let me see who got the correct answer. Sheldon, good job. Leon, good job. Aaron, good job. Cici, good job. Good job, everyone. Kathy, might want to think again. Leon, good job. Okay, let me see. Rachel, good job. Mina, good job. Simon got 5p. I think you must have, yeah, 559. That's correct, Simon.
I typed it wrong.
Yeah, you typed wrong. Okay. Yeah, so that is all for today's revision session. It is fun having learning simultaneous equations together with you. I hope you enjoy the rest of the evening. And if you have another question, you can ask me. If you don't have any other questions, you can leave Zoom.
How can you watch the replay?
Yeah, I will send the replay in the WeChat group.
Okay, thank you.
So that's where you can find it. Okay, let me stop the recording.